Okay, let's turn time over to Razul then. Thank you.
Should I use this one?
Is this one on?
I will just use this one. It's okay. All right. Well, good afternoon. Now, how does this work? Okay. I suppose you had a long morning and we just had lunch. So the good thing is that this is the last presentation. So for some reason, we kept it for the last. The bad news is that because it's the last, I can talk as much as I want, right? Okay, so I am talking on behalf of a group we call Energy, Fluids, and Minerals. So this includes conventional, unconventional oil and gas, but also anything that moves, which is resource, but moves in the subsurface. So energy, fluids, and minerals. So that's including critical minerals. As you can see from the list, this is going to be a teamwork. So I would like to acknowledge some of our members at EGI. Pitch, who's perhaps the most senior scientist at EGI. I mean, his service goes back to the 70s. Tony Dore, Dr. Dore, he is here from London, so it's good to see him at least once a year. Myself, well, this year we are celebrating the 50th anniversary, so I have been with EGI for 20 years. So that's like 40% of EGI's lifespan so far. Then H. Setoyama is also here. He will also share with you with some of his research work. Palash Panjam, Chris Kessler, Thom, they will do some demos of the databases, data apps which we have. I think you have met Regina. She joined EGI early this year, so she's on corporate relations. We are in the process of hiring a sedimentologist, a seismic stratigrapher, and I think we have also already hired a staff member to do social media, etc. So that's us. So most of the talks this morning which you heard are related to federal funding, state funding. In our group, we have also submitted, and we are submitting federal DOE or NSF projects. But what I'm going to share with you is related to the industry funding. So at EGI, we have basically, so far as our group is concerned, we have basically three, I would say, units in terms of services. The CA program, which is an annual-based subscription, mostly oil and gas companies. I think Milan this morning shared with you some of the benefit package which we have. But the meat of this package is really the EGIConnect, which has all our data repository, 900 reports, thousands of data from thousands of it, etc. So Christopher Kessler will show you what we have so far. Then the second unit is basin studies, regional studies. So we have several projects in the pipeline: Guyana-Suriname Basin, Red Sea, Gulf of Suez Basins, gas basins of Africa, and source rock organofacies mapping. So I think we will share with you some of the things that we are thinking about in terms of doing for regional studies. And the third unit is data analytic apps. These are, again, web-based apps, databases. iCORDS Offshore, again, you will see some of it. Critical minerals, Shale Smart, which Palash will show. And then SmartPack, this is something that Regina and Palash are working on. It's related to production forecasts. So Guyana-Suriname Basin, this is one of the, I would say, hottest spots in the oil and gas exploration. Back in August, when I attended the Image conference in Houston, there was a whole session. I had never seen a whole day session, devoted to a single basin. And I learned a lot. Apparently, outside of shale, this is the only basin that has had most reserves growth since 2014 or so. More than the Middle East, you name it. So it's really an important basin. Also, well, several companies, Exxon, Hess, Total, etc., they are involved. So what we are trying to do as part of this project, we have had some legacy data and also legacy samples. So we have done new analysis, geochem analysis of source rocks from pre-Lisa exploration wells. So these are really precious wells. Even some of the companies may not have any access to those because they're pre-Lisa, exploration wells. So we have about 200 geochemical data for 200 geochemical samples from source rock from 10 different wells. So that's one important component. Also, for those wells, we have integrated new stratigraphic charts, biostrat, lithostrat, etc. And then we are also doing our own paleofacious maps for different time horizons, Jurassic through the Eocene, I would say. So these are also important, really adds important value to the package. Now, paleofacious maps, some of you may wonder, well, Exxon is already there, Hess, so why do we want new paleofacious maps? But if you are an exploration geoscientist, you know that this basin, hundreds of thousands of miles, right? And the well is like on an inches scale, 10 inches, right? So you want to drill in the right spot. Anyway, this is one project that we are working, and if you are interested to discuss this more, we can share more information. So for EGI members, this is 30K, and then for non-members, 40K. Another regional project that we are working on is Red Sea, Gulf of Suez Basins. So this has two components. One is the ArcGIS database, our interpretation of well geochemistry, etc. But also a more important component, I would say, are the seismic sections, seismic images, 2D, and also well logs, which we have reprocessed. And there are more than 1,000 SegWi and LS files. So these are also parts of the package. So that's why they priced a little bit higher. I did not put any slide on that, but we are also trying to do a regional project in East Med. Now, given the conflicts between Russia and Eastern Europe, East Med is a logical, really, source for, especially for natural gas for Europe. So we are in the process of making some connections with Egypt and other countries in the East Med to get some data and analyze them here at EGI. Okay, now I will turn the podium, the microphone to my colleague, Dr. Setoyama, and then he will share with you the gas basins and also other projects.
Okay, hello. So I'm going to present two projects here. So one is gas basins of Africa, and the other one is machine learning project on organic geochemistry. So as Rasul mentioned, there is a huge urgent demand for additional natural gas sources, especially in Europe. And in general, the demand for natural gas has increased in the last years because of its role as transition fuel. And because of these demands, domestically in Africa and also in Europe, people are now looking at Africa very closely. And EGI, in the last 50 years, EGI has delivered more than 100 reports on Africa. And in this gas basins of Africa project, we are going to conduct a meta study which should help you identify stranded gas fields, which may have now become technically and commercially viable. And also to support your effort to reduce carbon footprint during operations by high-grading basins with hydrocarbons associated with lower greenhouse gas emissions during their life cycles. So for these meta-studies, we are going to compile and synthesize data and information from EGI reports and also public data sources, making them available on ArcGIS database. And in addition to this database, we are also going to prepare a report in which we will quantitatively and critically evaluate and rank basins or gas fields using common rating scales. And the use of the common rating scales is very important, because if you are using different rating scales in different databases, your comparison is invalid and not really reliable. Okay. So this is the template we have so far for this project. And each point we will use, for example, to rate technical difficulties or political or environmental issues which may have hindered the development of a gas field, but which may have become, and we will also use these ratings to high grade, again, stranded gas fields which may have become technically and commercially viable. So we are still in an early stage of this project, and if you are interested in, please talk to us, and we are more than happy to set up a meeting with you and discuss how we can shape this project and make it more relevant to your use. Okay. So now we move on to the projects with data science application. So in the last 8 years or so, we have successfully completed 3 EGI Oceans projects. And the key deliverable of these 3 projects was source rock evaluation using our unique workflow. And this workflow was designed to deal with inherent problems or issues with pyrolysis analysis, which is commonly used when you do source rock characterization. Okay. And these the inherent issues are related to the mineral matrix effect and the use of generic organic matter classification. I'm not going to talk about these technical things, but what I want to show here is that their implication is not negligible and can be very significant. So I have 2 examples, one from offshore Guyana-Suriname, and the other one is from southern South Atlantic. So what you see in this figure, so on the left side, so you see the source rock characterization just using pyrolysis results. So this is what you would get when you do evaluation just using pyrolysis. And on the right side, what you see is the collected source rock characterization using our workflow. And what I want to demonstrate here is that if you are just using pyrolysis results, you may be, there's a chance or risk that you may under-evaluate your source rocks. And your perception of your source rock could be wrong. And in the reality, your source rocks could be more oil-prone and might generate more hydrocarbons. And such under-evaluation is, I believe, that is not what you want, especially if you are in frontier exploration. You can miss huge opportunities like, for example, Guyana-Suriname if you just ignore the mineral matrix effect and the problem with the generic organic matter classification. So to deal with these problems, we used visual analysis of organic matter in our oceans projects. But unfortunately, this analysis is time-consuming and requires additional funding. And now we have accumulated a lot of data through these organic EGI Oceans projects. And we are also building a global database based on literature to use as a training data set. And we are now building a machine learning model which can detect stratigraphic intervals affected by the mineral matrix effect, correct for the effect, and predict the organic matter, more reliable and more detailed organic matter composition. And this model should work with the data you already have in your well reports. So you do not need to do an extra additional analysis. So this is the key deliverables of this project. And as I said, we are building a global database, which should be, I think, will be useful for you to learn which stratigraphic intervals are susceptible for the mineral matrix effect in the basin you are interested in. Okay, so this is all I have for these two projects. Now I pass this to Parash, I believe. Yeah.
I don't know the next slide, so that's why I was sitting there. What's the next slide?
Yours.
Oh, it's so at EGI, my name is Palash Panja. I'm a research assistant professor in the Department of Chemical Engineering. I'm also a research scientist at EGI for last 7 years almost, starting from 2015. At EGI, we are developing many web-based applications nowadays. I think people don't like desktop-based application or installation nowadays. They like web-based application. So Shale Smart is one of them. So this is different project. This is not the SMART project Professor Brian McPherson during carbon management mentioned. That SMART project is different. This Shale Smart project was actually conceptualized many years ago during the liquids from shales project PI by Professor Milindio in 2012 or 11 to 2014. We had like 15 companies. So that time I was PhD student, and I had my colleagues or other PhD friends. We developed many tools and during our PhD work, and we did not develop any commercialized tool that time. So when I joined EGI, then we thought that we can make them profitable, we can make some application. But here you can see there are like five columns, but we have more tools actually out of these 5 columns. Many of them came from our PhD work. Many of them we developed recently with Dr. Rasul and our software developer, Thomas Cook, and system administrator, Aaron Baker. So first one is the reservoir characterization. Here we are interpreting the log data, and you know there are so many log data like resistivity log, density log, and so many logs are there, and there are so many equations are there. So Rasul investigated that, and we have summarized all equations. There are like I think 7 and 8 equations just to tell you the porosity. So in this model, you give us the defined log, and we'll give you the porosity, water saturation, and TOC. And you can choose which method you want to use. There are many options, okay? And another application in the reservoir characterization is material balance method. Basically, it is, we are calculating permeability from material balance. If you have production data as input and PVT data, fluid PVT data, we can tell you the permeability of the reservoir. So this was done by one of Dr. Dev's student, Raul Velasco, and we have implemented that in the Python. Second one is the Yeah, 3D modeling using the ISOPAC image. Image is like PNG format or JPEG format. We need thickness ISOPAC. There is one software in the market, it's called Surfer, and we tried that. We uploaded our image, the JPEG, and it did not recognize even those lines. That's why we developed our own model. One master student was working in that, and you can see we perfectly captured all those ISOPAC, these white lines, using our own model, own Python code. So we have done all these models we have done in the backend. Already Python codes are done. Now we are developing UI and UX model with our software developer and administrative system administrator. And so if you give us the image, ISOPAC image, like thickness ISOPAC, porosity ISOPAC, any other ISOPAC, we can calculate OIP, originally oil in place or original gas in place. And we can, of course, area of each contour we can calculate. There are many complex mathematics because they are not perfect circle or they are not perfect eclipse. So we have used many complex mathematics to calculate the area and volume also. And third one is like called, it's part of top-down modeling, TDM. If you have longitude and latitude of wells and point source data from core, like permeability, porosity, water saturation, if you give us that, we can plot them, the location in the map. Also, we can define the boundary. You can give us the boundary, or we can define our boundary automatically using that our model. And then we can distribute all those properties. Like if it is porosity, we can distribute the porosity using kriging or artificial neural network. We have both capabilities. Then we can assign individual area for individual wells using the Voronoi diagram. And Voronoi is very famous in the reservoir simulator. And then we can average the properties for individual wells. So how it is useful for you? So you can calculate your OIP for individual wells. Also, you can place any new wells in any location here. Then we redistribute entire area among the wells again. Then you can calculate your field development plan, whether that new well is profitable or not. So that backend is also done. We are doing the front end programming. The third one, the data analysis. Rasul and I are working for data analysis for like last 2-3 years. We had more than 200,000 wells data. Then we filtered those data based on some criteria, like at least we need 2 years of production data, otherwise we cannot analyze. Then we had like more than 70,000 wells data. Based on that, we prepared almost 25 meaningful graphs or figures to investigate different criteria, like what's the effect of technology. Then what are other effects? Like what are the effect of like completion? So we had data for lateral length, we had data for true vertical depth. Based on that, we have published a couple of papers in SP, ATC, UATech, and we have developed the backend programming based on all those 25 plots. And now we are developing the front end. So last one is the production forecast. It's based on the surrogate model. The surrogate model could be normal polynomial model, artificial neural network, and support vector machine. So if you give us the geologic data, completion data, we can tell you the recovery factor, oil rate. And you can do sensitivity studies, you can do uncertainty analysis also. Sometimes we have uncertainties in our input data like permeability. Permeability is log normally distributed in the field. So if you give us log normal distribution parameter like standard deviation and mean, we can give you the uncertainty or probability diagram in your recovery factor in the output. So all these things are done in the backend. Python programs are done. We hired a couple of master students and bachelor students. Now we are developing the front-end programming. So once our beta version is done, we will ask our CA members to test them, verify them, whether they are looking good or not. Then we'll move or improve that things. So I have taken more than 2 minutes.
Thanks, Palash. Yes, as Palash mentioned, this is a web-based app. So even if you don't want to give us your data, you can use it, export your own data and use it. So this is also subscription-based. Okay, what else do we have? Let's see. Okay, yes. This is applicable to shale only. Only shale, yeah. Well, tight formations where you need to frack. It is shale.
But the surrogate model is based on shale. Yeah. But Voronoi diagram, I think it's general. You can do anything. Yeah. Yeah, for the last, last one, the production forecast is based on shale. Yeah, number of fracture spacing, we need all these things. But like field development, this Voronoi diagram, you can apply for anything. This one, I think you can apply for anything. But log interpretation, I think you focused on only on conventional shale, right?
Okay, I think the next thing we are going to do is to impress you with our EGIConnect. So Christopher Kessler is going to give you a demo of what we have on EGIConnect. So how are you going to do that?
Hello, Christopher Kessler. I'm the Institute's Geographic Information Data Manager. I know some of you, our CA members, are familiar with EGIConnect. It has changed somewhat, but the look and feel are pretty similar to the previous version of it. So EGIConnect is available at our website. The fastest way is here in our quick links. We're using ArcGIS Online to pull up EGIConnect and the associated data. So EGIConnect is available. It's visible to the world. If I can get it to come up. So slow. Here we go. Anyone can see this map. Anyone can browse the map. They can click on any feature. They can browse our tables. These are out of our database, so these are all of our reports, including some that are in our possession, but not necessarily published by EGI, so these are other reports. But the fastest way is to go in. You can click on an item. This is a completed report. You'll get a pop-up. It gives you some description about what that report is. Anyone in the world can go ahead and review our project summaries and abstracts. We do hold in reserve the actual data and reports for our CA members, and that's this other link down here. So a CA member can come in anytime they want, and if they would like to request a report, they just click that link, throw in their name, company email, submit, and we'll get a notification, and then we will get back to you as quickly as possible with a secure download link that comes straight to your email. You can also take these tables offline if you just want to export our listing of reports. You can do that from here. There's also listing reports on our website, so either way, they're in sync and the same. So if I zoom in closer, some other data will come online. So we have our other reports. These are these kind of pink ones here with the P in the middle. So those are other publications, and then theses, and then the blue M's are maps in our possession. So if any of you are coming over this afternoon to EGI, I'm happy to show this even in more detail to you if you want to have some questions. I'm kind of limited on time right now, but I can definitely sit with you and we can go through anything you want, discuss EGIConnect this afternoon. Thank you.
Thank you, Chris. Okay, so EGIConnect is an ArcGIS Online. So another data app which we have in there is a critical mineral database. I think Milind referred to this in his talk this morning. So this is a huge database. We have about over 400,000 geochemical database for samples from all over the world, onshore, offshore, mostly rocks, but we are also adding brine and the oil field geochemistry. That's something, a work in progress. It also has, so that's the upstream part. The downstream, we also have included over 300,000 mining locations, again, all over the world. So it's both upstream and downstream. So again, we are adding lots of data. It has some visualization, plotting, data analytics. Again, this is, right now it's ArcGIS Online, but I think we are moving it to Google Cloud, and that's why, Tom and others, they are writing a new code for this to create a platform. So maybe, Christopher, you can just show a few, I don't know, a couple of examples or new features.
Yeah, so as Rasul just mentioned, this is not how the app is going to look. We're just using ArcGIS Online to more or less show the distribution and the amount of data we have. It's a little overwhelming for ArcGIS Online because we're talking hundreds of thousands of sample locations, sample data, which if you take that down to a unique location, it's about almost 78,000 data points with any number of samples at each location. So you're looking at a map of locations that Rasul has pulled together over time. And each one of these positions right now, I can click on one. The idea would be to say this is one location. And I have some basic information about that location. And then down here, we'll give you an actual link to the actual data. So you got your full reference of where it came from. Some same information you'd see at the location, but if you scroll down, you're going to start to see oxide information, so different mineral oxides, and then the individual element concentrations measured at that location. And we have that for every point on the map has some information like that.
So over 400,000.
It's not quite that on the map yet because I haven't imported another data set that I was given recently, but it's very near 400,000. To make life a little bit simpler, we broke down the elements into their individual parts. So let me turn off the locations quickly.
So these are the critical elements that USGS have identified.
So I'll just
52.
I'll just throw up lithium, and what I did was I kept the dots the same, but the hot spots you can see in like the darker red and the darker colors are higher concentrations of lithium. You can select on this map if you wish, and the application that our programming team is going to build will be work the same way. Select a few locations, find my lithium. If I want to see the actual data in the table, I can do that. So I got 154 samples back.
Zoom in and maybe overlay geological map.
So I can't show you those; they're not published.
They're not
No,
published yet? Okay.
yeah, we can only do the dots right now. But I can show you that if you come over today. We can dive into this a little bit further too.
It has lots of supportive maps, geological maps, infrastructures, etc. So it's a huge database.
They haven't been published to this app at this point. So if you like what you see after you've made your selections, just much like EGIConnect, you can go ahead and export that to a table for use offline on your own. And it is possible to filter this table down. You can perform a filter on the table. You just have to add your own expressions. So if you have a location in mind, you just pick a location based on country, administrative unit. So it would be like states in the U.S. So we can do let's change this to a unique value. So we can say, we can go ahead and do Utah since we're here. And so the lithium, so this is the lithium layer, so I can't do cobalt. So, and is at least, and then whatever criteria, just do, I don't know. So I'll go ahead and pull up 800 values, clustered there, right there in Utah like we wanted. And that list can be taken offline. Once you export that, it'll be your third list of Utah lithium values greater than 4 ppm. Mining locations I can show you, or the mining companies I can show you at the Institute. I have them mapped. They are not published to ArcGIS Online. There probably is a layer on ArcGIS Online that does have something like that already in existence, but yeah, we didn't put that in.
Trust us, it is there.
It is there.
Okay, thanks,
Yeah.
Christopher. Okay, the next stop. Okay, Tom Cook is going to show you the iCORDS, and let me just show the PowerPoint first. This one. So this iCORDS, I mean, we have been working on iCORDS for almost a decade or so, but iCORDS version 1 was kind of fragmented. One database like pyrolysis didn't talk to stratigraphy didn't talk to. So anyway, companies were having a hard time actually to use it. So we started from the scratch. We did a quality check on data. We expanded the data, and also Tom wrote a few codes, which you will see. They're amazing. You can also interpret the data on the spot. You don't need to export it, in fact. You can do it if you want, but I think our data analytic tools are much better. So you can use these tools on the spot and do interpretations. So this data comes from various sources, really lots of sources, Europe, US, international, etc. So if you need more information, we have a flyer, and we can also have a demo for your own company. Actually, next week we are going to have a demo for a particular company. So, okay, so this is how to log in, and Tom, it's yours. It says over 12 million samples. 12 million samples. So it's huge, from thousands of wells all over the world. Offshore, I should say, offshore, deep water. So this is a good screening tool for deep water exploration.
I thought Rasul was going to do all the talking, so. So first off, I know that you guys are generally interested in a place geographically, so we have our area of interest tool that we can use. Now that's amongst 240 different things that you can filter on. Different categories include wellheader parameters, samples, stratigraphy, etc. You'll see more of that in a bit. And then specifically for well headers, the area of interest that it's in, the name of the well, how many samples it has, basins. And like I said, we've collected about 240 different parameters. Actually, no, 50 that you can filter on, but there's 240 different parameters in the database. We've tried to make this very granular so you can return exactly what you're interested in.
Tom, just one moment. So as you can see, there are 4 zones. So this is the map view. All the maps will appear here. This is your query filters, if you know the way you are querying. So the parameters will be here. This is the data table. What you are querying will appear here. And then these are the different data categories that you can query. Let's just review one by one, just the names. So wellheader, samples, stratigraphy, TOC, pyrolysis, thermal maturity, petrophysical properties, sonic velocities, and gas analysis. That's what we have done so far. We will be adding oil chemistry as well.
So going back to our example, we've selected around Gippsland, but let's also find out, let's also find out what was from the Cretaceous period. So in our stratigraphy, select the period, type in Cretaceous, and we'll just do the samples that are exactly in the Cretaceous. Then the third thing we'd like to know is in that area, in that time frame, when was the TOC greater than 1? So those 3 filters act together. And we're going to do a pre-search. And the reason is we don't know how much data you're going to come back. We have 12 million samples. So we have to make sure that you don't overwhelm the system. So our estimate is that will bring back 1,200 rows. And that's fine. As long as you're under 10,000, we'll allow you to do the query. So now we'll actually return the data. And it should come back usually in less than 30 seconds. But in this case, I think 5 seconds is more like it. So that tells us that 64 wells were found that had those parameters. They had 1,254 that were, in the Cretaceous period and had a TOC of greater than 1. And the measurements are like this. Sample depth, the period is a measurement and the TOC is a measurement. So you can take this data and then download it to an Excel spreadsheet and go ahead and use it in your research. So it's that easy to just pinpoint the exact time period, geographic location, and geophysical properties that you're looking for in order to do your research. So that's our first example. Did you have any comments on that? Okay. So for our second example, I'm just going to push this button. It's going to take everything back to the base state. And we're going to look at a specific place, a specific basin called Anderson.
This has been rehearsed, so to save time.
Now this time I'm going to put more emphasis not on what we're filtering on, but what's going to be returned. So under pyrolysis, I'd like to know S1, S2, S3, Tmax, hydrogen index, and production index. Sorry, oxygen index. So let me remove that. And there we go. And that is now what we'll be returning on. All right, 556 rows will come back. Little note here, it said 89 of those rows didn't have any data, so we just removed them for you so you don't see a bunch of just wasted rows. Correct. Yeah, we are now centered on every single well that we're talking about, and as we click on everything, you can see which well we're talking about as well. So we'll go ahead.
So you can zoom in. Let's go to full view of the map.
Oh, yeah.
You can zoom in, actually export the map as a JPEG file for your PowerPoint presentation to your exploration manager if you want to. So yeah, let's go back. Thanks.
Sure. I need to go back though. Okay, so for the well information, if I went to any well, clicked on it, it'll give us a little bit of properties, but if you want to know everything about the well, just push this button. It will bring back pretty much a graphical representation of everything we know about it. You can see that there are 12 samples in this well, You can see that it has a total offshore depth of 25.6 meters. You can scroll down to see a magnification. And if the samples are really close together, you can magnify on that any more, or really, really close. Sometimes samples can be 2-3 centimeters away from each other, but the well can be 10,000 meters deep. So it's really tricky to show everything. Now, if you click on one of these samples, then you can learn everything we know about it. We have 18 different categories, so I have to scan through the whole database and say, what do we know about this in category 1, category 2, category 3? So it takes a few seconds to come back.
This is really Tom's magic. We did not have, I have never seen even this. So when we were brainstorming, he came up with this procedure. It really saves lots of time for you.
So of the 18 categories, this sample, we know some pyrolysis information and we know some TOC information about it. So this is comprehensive. And this is when we say we have 12 million samples, we have 12 million of these blue lines. Then we have all the measurements, and you can see in this case there's 20 measurements. So take that 12 million samples times 20 measurements. We must be in the tens of millions to hundreds of millions of measurements. So there's all of our S1, S2, and S3 Tmax measurements. Now, it's very important to know where data came from. So if you click on data source, it will actually take you to where the data came from. Canada isn't very convenient. They require you to do a second search. But sometimes we'll go to an IODP or DSDP, and you'll just see the grid of data from which we got it. I mean, what we're trying to accomplish here is consolidation. All of the information in one place for convenience. Plus, we tell you where the information came from.
This is important. We are not IHS. It's not a black box. I hope so. Those of you who are working for oil companies, you know what I mean. So, yeah, we are very honest with the data because we have done quality check, actually. I mean, it says taking like 18 months.
Right. All of the negative densities have been removed.
Yeah. Would you believe that, you know, the SDP had reported negative density? I mean, how can you have a negative density, right?
And we literally had debates about that.
And it's a rock. Anyway.
So that's the information.
Yeah,
Go ahead.
they live in a different universe. So.
So that's the information about one well. But of course, what we're trying to do is take a sample across an entire large area. And so down here, you know, we got, 467 rows back. But let's try to like summarize. Of these wells, if I click this little frequency, and I have no idea how to pronounce this, Kabami well has 151 samples that fit our criteria. The Stony I-50 has 88. I'm going to grab this actually. And then you can see the breakdown. So we're trying to not only bring you back a lot of data, but help you with the analysis of it. So that shows us the frequency of the wells. What depths were all the samples at? So I'll just go ahead and select on depth, check the histogram, and we can see that about 115 were between 0 and 400 meters, 96 were between 800 and 1200. So you can get a feel for the data just at a glance really easily.
This is a screening. I mean, the richness of data per areas, etc. Okay.
And then finally, we can do some cross plots. What were we going to do? Pyrolysis versus depth. So pyrolysis on the x-axis.
Tmax versus depth.
Sorry, got it wrong again. Yeah. Tmax on the x-axis, and then depth on the y-axis. Is that right?
Yeah.
Okay. And so it brings back this kind of clutter of data. Now we can go back and say, well, I think I'm interested in Stony I-50, and we can just narrow down all of this to that so we can just see one. I don't want to do that at this time just because we have limited time. So yeah, we try to bring analysis tools to you, but our favorite analysis tool is the next one, which is what we call the Pyrolysis TOC VR report. So I'm going to select every single row and then push this button. And we literally get 9 reports back at the same time over that entire data set.
So these are the analytical tools. These are interpretive data. So we took those data and then we are interpreting them for you. We haven't done this. There's also a module where thinking about you can export your data and then use these plots if you want to. That's the next step. Yes.
So we'll go left to right, top to bottom really, really quickly. This mentions all of the well names. And if you want to, you can de-emphasize and then see just the information about one well, or maybe one or two at the same time. So that helps you get clarity through all the noise. And as you can see, there can be an awful lot of noise. So I'll turn them all back on again. And this is a histogram that also has the ability to focus in on the area of interest. So say you really want to know its depth, you can do that, but you can change the histogram. Let's say that you're very interested in S1, and then we can focus in around S1 values between 1.8 and 2.4 have now popped out on the graph. Again, how do you get the signal out of the noise? That's always the trick with mass data sets. I'm going to set this back to
Tom,
depth.
just so
Go
they're not
ahead.
noise, they are real data, valuable data. But if you would like to zoom in an area of interest or a particular depth or particular range in TOC, etc., you can do this.
I always use computer terms. He always uses geology terms, so we have to still work that out. This is a really quick glance at the wells, their depth, and you can see how ridiculous the number of samples can be in one well compared to another one. And I think that's what's been so interesting is just the diversity of the sampling on the data. But that's why we provide these tools so you can see that. So let's look at more geochemical stuff, and I'll hand this over to Rasul. So this is production index versus Tmax.
Yes, so that you have different fields. It would give you immature versus all the way to dry gas. So those data plot in a particular field. So these are routine geochemical, I would say, tools, but it makes your life easier, you know.
The next one we have is potential yield versus TOC. Okay. Any comments?
No,
Okay.
I think they
Ne-
know what
Sure. You guys know more than I do.
kerogen type.
Hydrogen index versus oxygen index. And again, we're trying to provide all these helpful tools. This is where it's oil prone. This is where it's gas prone. This is where it's type 1, type 2. We're trying to do that wherever we can for you.
And you can export this, right?
Correct. So if we hit this button, I actually momentarily take away that because I don't think you want that in your diagram. And then it downloads it for you.
The JPEG file, then you can export it to your PowerPoint.
And it's a fairly high quality image. I don't think you'll have any problem with resolution as you kind of
Right.
zoom in.
It's-
So, okay.
So a few months ago, when Chevron was here, Barry Katz, so it's not easy to please Barry Katz, you know that. So he liked it. So we are very confident about. Do you know Barry Katz already? Yeah. Okay. Good. So
Did you want to look at any of the last three, or are we?
no, I think this is good. Anyway,
Okay.
these are interpreted, geochemical fields, basically. Okay.
And so now we're going to go off of the geochemical for a bit and show maps. And I think we'll be finished up at that point. So I'm going to just remove the run. And then we'll go back to the map. I guess I'll make it full size.
Good.
And then I think you wanted to look at
Yeah, let's go
UTIG.
with, so we have some map layers. So let's go like ocean floor age, for example, here.
Okay. Did you want to bring down a seismic map?
No, just let's go with map layers first, ocean floor age.
Okay.
So these are some maps that you can use. You can zoom in. This is the isochron map for the age of the ocean floor, for example. So if you want to know what's the oldest oceanic cross close to your continental margin, we have not created this, this has been created by others, but we have really included them in this database. So it makes it easier. Then there's another good layer on heat flow, for example. Heat flow. So it's like 60,000 heat flow data points all over the world. And each one of them has a value. These are color coded. So hot colors are, high heat flow. But anyway, there are lots of games you can play with these maps. But we also have seismic data. Maybe you can turn off these maps and then go to.
Okay, I was going to do the NGDC if that's okay.
Yeah, sure. So these are, I don't know, over 5 million square kilometer of seismics. Again, they come from different data services, Canada, Australia, you name it, US. For some of them, we have the original data in the form of usually TIFF files.
Mhm.
So you can maybe download that. So this is, of course, you
So-
can zoom in, your geologist will have a nightmare to interpret this, but these are like, 2D data, 60s, 70s, 80s, something like that, but they are useful.
Yeah, I think we have 15,000 of these tied to this
15,000,
layer.
Yeah, over 5 million square kilometer. And then other seismic services we have, let's go to, for example, UTI, University of Texas.
Okay.
So we also harvested their seismic, but for the sake of, because these are huge files, so we only give you the links so that you can go and then register and then download the data. So at least you have the address, the directions, where to find them.
Right. So again, trying to go back to
Yeah.
the original source, consolidating stuff in one place, and then referencing you back if we have to, or storing the data when we can.
Okay, I think, anything else?
No, that's everything we had on the
Nothing,
list.
So anyway, this is available for sponsors, and we are very proud of that. Thank you very much for your attention.
Yes, thank you much.